All right, so today we're going to talk about coterminal angles. Coterminal angles are basically the root of what we're going to do this year. And so they're done in a way, oops, wrong pen. There we go. They're done in a way, that's how we form the right triangle. So in trigonometry, we really focus on the coterminal angle. So what is a coterminal angle? Well, it's two angles in a standard position, with the same terminal side called coterminal angles. So it's the forming of the right triangle, all right? It's the forming of the right triangle. So if I have, let me pull in an XY plane. So a coterminal angle, and we'll do example number 1. I'm going to do it as I explain it because maybe it'll make more sense. If I think of alpha being an angle that is 635 degrees, that means that I am going to start my angle right here, right? Hey, this is for you, banana face. So I'm going to start right there, and then I'm going to rotate because it's a positive angle. Because it's a positive angle, I'm going to rotate counterclockwise. So if I go one, whoops, let me redo this, make that a little skinnier. If I go one revolution, from here is 90 degrees, right? Remember, this is 90 degrees. This is 180 degrees. This is 270 degrees. And then this is 0, but it's also 360 degrees. So if I make one full revolution, that's 360, right? So what I need to do is figure out how many quarter turns I'm going to do. So I could divide this by 90, right? So let's do that. Let's say 635 divided by 90. And I get 7 point blah, 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 right? Well, what is 7 times 90, right? We could do that in our head. 7 times 90 is 630, right? So plus 5 degrees. So I've gone 1, 2, 3, 4, 5, 6, 7, and then 5 more degrees, which would be about right here. So this is my measure for theta, right? But what I really want to know, because at some point in time, we're going to have to form a right triangle. So the coterminal angle will give me the same exact opposite hypotenuse situation as the angle itself. So the coterminal angle is always going to be this little sliver right here. Okay? Or it could be just one revolution, right? It could be that I just go from here to here. So the convention normally is, and we'll do both the positive and negative, right? If I say, if this is only 5 degrees from here to here, and this whole thing is 90 degrees, what would this angle theta be? 85, right? Let me make that a little smaller. So I'm going to do prime notation. So I would say alpha prime could be, now if I go this way, isn't that negative, right? If I go this way, isn't that negative 85? So that could be a negative 85 degrees, okay? Now if I do one full rotation, I go 90, 180, 270, 275. So another angle, and we'll do double prime, could be a positive 275. So now this is where it gets a little tricky. Sometimes what we do is we could subtract a multiple of 360. In other words, what is 635 minus 360? Well, if I say 635 minus 360, guess what I'll get? The 275. But sometimes that works and sometimes it doesn't work. Sometimes you'll have a very large answer and then you'll have to figure out, you got to multiply 360 by a certain amount, okay? I always like to sketch it out like this. It's just my process. Sometimes the more stuff I write down, the more stuff I do, because I have to think about it more, it helps me. I see some hands up. Yes?
I don't understand how you got the 85 or 275. Like, everything you looked at it.
Okay. That's a good question. What was your question?
Where did you get or like, why use the alpha prime?
Oh, okay, good. Those are good questions. Let me address the alpha prime, alpha double prime. I want you guys to see that the reason I use the alpha prime notation, this angle is not necessarily alpha. Alpha is 635 degrees. We're asked to find the coterminal angles, right? Oops, let me do this. We're asked to find the coterminal angles. Now, the coterminal angles is the angle that gets us right back to the x-axis. That's the easy way to think about coterminals. What angle forms a right triangle off of the x-axis? Okay. Well, what could it be? Well, if I go from here to here, right? In other words, let's back up. 635 degrees means that I went one full revolution, that's 360 degrees, plus another 90, plus another 90, plus another 90, plus 5. That's where this line comes from. Okay? So watch what I do. We start here on the initial side. We rotate around 360 degrees. I'm trying to graph 635, right? So I go 360 degrees. Not quite 635. So I add another 90. I add another 90. At this point, we are at 630 degrees. How do I know that? Because we went 90 plus 90 plus 90 plus 90. That's 4 times, 5 times, 6 times, 7 times. 7 times 90 is 630 degrees. We need to go 635. So from here, I just need to go 5 more degrees. Does that make sense? Okay, so now that I know that the measure from here to here is 5 degrees, and I know that this is a right angle here that's 90 degrees, if this is 5, then from here to here it has to be 85, right? So this angle is really 635. But a coterminal angle gives me the same value for my opposite, for my hypotenuse, and for my adjacent. Well, what is that value? Negative 85 will work. Well, what's another angle if I do the positive angle? Well, if I go in the positive direction, I go 90, 180, 270, plus 5. Does that make sense? Did that help?
Why do you do it the second time then? Like the 275 part, why can't you just stop it?
well, we don't know if they want us to have the positive angle or the negative angle. They're two separate things. And it wants us to find both. Okay. I agree with you. If we did the minus 85, that's probably a lot easier for everybody. So, for fun though, grab your, I didn't pass out the calculators. Just watch the screen. So if I say sine of negative 85, this is what we're trying to find, okay? Sine of negative 85, I get 17.6 or whatever, right? Is that in degree mode? Let me check something real quick. Yeah. Okay, that wasn't in degree mode. So watch this. If I say sine of 635 degrees, I get this, negative 0.99. That's a legitimate answer, okay? Now, if I take sine of negative 85, guess what? I'll get the exact same answer. If I take sine of 275, guess what? Exact same answer. So I agree with you. It'd probably be a lot easier to work with if we just did the negative 185, but that's why they're called coterminal angles, because all of those angles are going to form this angle that I have in red, and at some point what we're really going to focus on is the opposite side length, the hypotenuse, and then of course the adjacent, right? We're going to focus on these three sides of the right triangle. So rather than plug in 635, we'll probably plug in negative 85, but there might be a situation where it'd be easier to do the 235. That's why I'm trying to show it all to you. Okay? Does that help? Okay, do you guys feel good about that? Let's try it again with beta. Okay? So now for beta, let me make a copy of this. I'm going to slide down here a little bit. All right, so for beta, we're basically going to do the same thing. We always start at the initial side, which is right here. And now we're going to go negative 85. Well, I kind of talked ahead of myself, right? So if I go negative 85, how do I know what that looks like? Well, it's gonna come here. And so for this particular one, this is beta, which is negative 85. Right? We know if I were to imagine an angle right here, this would just be 5 degrees. Whatever it is, positive or negative. We know that that's what it is. And it says determine if they are coterminal, right? So the question is saying, is this coterminal? Yeah, I guess I see your question. Why did Mr. Adams go on and on about this? Right? Because, I don't know, I just threw it in there. I wanted you to know it. Okay. Are there any other questions on this one? And so essentially, I drew this angle by going this way.